got another project waiting for us. And in this project, I'll do my best to explain the concept of closures. This is a very important idea in JS. Closures, and there is a function inside the function, and that one function, inner function, can get and store and use values or variables from the other function, even at the point when this other function stops to exist. It's no longer existing, but its values from those variables are still very much alive in this other function. And maybe me just rambling about this doesn't make much sense, but as soon as we get down to it, I'm sure it's going to get a lot easier to understand. For now, just an intro, and we're going to do something very simple that is going to shed some light on the actual problem and how closures are helping to solve that issue. So here, index HTML completely empty. We've got just the script connecting to main.js. Main.js also clean. So let's say we want to create a counter. And let's say I'm going to create it. Let's call the number, and let's set it to 0. And then the entire body, so document body, or actually we don't need to type body, just add event listener. We're going to listen for a click, which we're going to pass as the first parameter, and we're going to fire a function add. Every time there is a click detected on the entire body here, we're going to fire that function add, which we're going to create in just a second as well. So const add, just use an arrow function. In here, what we need this function add to do is basically increment the number. So we're going to do this straight away, number plus plus, which is going to always increment by 1 every time there is a new click detected. And we're also going to display the message to our body. So document body, text content, property, and using a template string, we're going to say the current state of the counter is, and here we're going to inject the actual state of the counter using the $sign and curly braces. Here we're going to inject our number. There you go. It's very simple, so I don't think there is anything that we could do wrong, but it's slightly too small. Let's make it bigger. Let's maybe add a colon at the end here. And I'm going to click on the body. So you can see the number is increasing. Current state of the counter showing every time higher number. And before we actually move on and discuss the closure, do you see anything wrong with this project? So when we write those very simple type of tasks, it seems okay to put the number outside in the global scope, but this is not an actually good solution. This is a very bad solution because this is in a global scope and everything and anything has access to it. So if we try removing it from here and placing it inside here, so now only our add function has access to it, it seems like it could solve our problem. Let's save it and let's see what happens. So I'm clicking on the body, but every time it is actually updating, but every time I am clicking on the body that is listening for that click, it's setting number to 0, then increasing by 1, displaying the current state of the counter, after which I click again, add function is being fired at this event, and again, number is set to 0. So basically, this is not a good solution. We cannot place it inside, and it's not a very good solution to place it outside in the global scope. So this is our problem, and closures, which we are going to discuss in just a second in the next video, is the solution to that problem. Instead of placing something in the global scope or inside the function where we cannot actually use it, because this is not our goal to display 1 every time, we are going to use closures. Right, all about closure. So closure is a mechanism that helps us access a given value outside of a function and when that function is no longer active. So I've prepared like 3 mini nodes we're gonna work with. I'm gonna try to present on an example. This example, the first example, is a little abstract, but I need you to really focus and listen so that the kind of like the first message gets through. And with every other new example, it's gonna get easier, I promise. So I'm gonna create a function called x. In that function here, I'm gonna create a let call, let's say, number, and give it a value of 0. So far, so good, very simple. And inside the function, the next thing I'm gonna do, I'm gonna create another function called y, and this function's job is gonna be to console log our number from the outer function here. Outside here, still inside the function x, we are going to execute y, and at the very end, we're gonna call function x and save it. So for now, we have a function inside the function, and that variable number, it doesn't matter whether it would be created with a const, let, or var, it has its scope. So it's visible inside here. Any inner function can get inside or outside. So it can, is nothing weird about this console log getting that number from the outer function, because it has access to it. So if I'm gonna open the console so that we can see what is happening. We can see that 0 is being displayed in the console because we asked to console log number from here. Cool. So far, nothing weird about this. But let's say our function here is we are not calling y anymore, but we actually returning y function. Do you see how this changes? So for now, we're gonna create a const called example, because it's to show you an example of how closure works. And as its value, we're gonna call a function x here. So we know that whatever is returned by this value here, by this function here, your return value is gonna be the value of our constant variable example. If I'm gonna now call example, or actually show you what is inside the example, we'll see that it's a function, and this is exactly this function here, right? Because this is what we wanted to return. We wanted to return y, and this is function y. So our example that is storing whatever is returned by the function x is here. We can see clearly. Cool. And now if I'm gonna call example, we're still getting 0. So technically and normally, when something stops existing, like this function happened, but it was returning y, so it was storing only function y here, it should cease to exist. So this number 0 should no longer exist normally. Normally, when the function dies, whatever it had inside dies with it forever. But because here in JS, if we make a reference to another variable used by another function, even though this other function is no longer active, we can still access its variable. So we can still log 0. So again, closure is a mechanism that helps us access a given value outside of a function. So we are accessing number outside of a function inside another function, and when that function is no longer active, because this function x is no longer active when we are accessing number from here. Second point, closure. This is very similar in definition, but slightly different. The variable exists in another function. Correct. Although the function in which the variable was created is no longer active. Cool. So this is like rephrasing, but just making the statement stronger. And the third, in program memory, a variable exists if it is referenced by a reference from another function. We can access it, but also change it. Cool. So we don't only access it, the number, but we can also change the number because it still exists in the memory of the program. So for instance, if we were to declare another let, say name, and give it a string Alice, and save it, this name is not used in here, hence the reference to that variable is never created in another function. And as soon as function x ceased to exist, it dies, is no longer active, that let name Alice dies as well. It's no longer active as well. It doesn't exist. Whereas the number that is referenced, and the reference is kept in the memory of the program, we can still access it, we can change it. It's very much alive. And I do realize this is very abstract because we're working on x's and y's in here, but this is just to grasp the main idea. And now we're gonna move on to an actual, like a little bit clearer example. Cool. So what we want to do, we're gonna attach to the document again, add event listener, and we are going to listen for a click as previously. We are going to insert a function called counter, which we also going to create in a minute. But first, we are going to create a function called add. This function is going to be an arrow function. And inside here, we are going to create a let number, which we are going to set to 0 for now. Cool. And whenever we talk about closures, mainly we talk about functions inside other functions which are used to reference those variables. So instead of placing them outside in the global scope, we are closing them. So the function that is supposed to be using that variable is allowed to use it, and it's not in its own scope as such. So we, like previously, we had a problem that the counter was resetting each time and we couldn't like increment by 1 because it would always show 1. Here we are closing that variable in the outer scope, still having access to it, but closing it from the outside. So if it's not in the global scope, it cannot get in conflict with other parts of the program. Cool. So here we're going to create, it's going to return another function, just an arrow function, anonymous. And the job of this new function is going to be to increment the number by 1 and also console log as previously. We are actually not going to console log this. We are going to display the text to our body. So document body text content, and we are going to use the template string, so the backticks and the current state of the counter $sign curly braces, and here we are going to inject the value for the number. So far, you following, we have that click event listener. Anytime this occurs, we're going to fire a counter, but we don't have counter anywhere in the code yet. Correct. And so we're going to declare counter as well and set it to that function here. So very similar to our function x and returning y here. We are, as here we have created example and we gave it a value of calling a function x. And whatever is returned by that x is the value of the example. So here we created our counter function and assign it a value of whatever is going to be returned by our add function. Let's save it and let's see what happens. So I click on the body and we can see that the current state of the counter is increasing on every click. Every time a click is detected on the body, we have a higher number displayed. So I hope this is slightly clarifying the idea of the counter. I understand that the concept is not easy to grasp. Whenever I, at the very beginning, saw something like this, counter here, but here actually calling another function, and in this function here we are returning something else yet, I would be like, what is this? But it's very simple. You just need to take it step by step. We understand how the add event listener works. Anyway, we are listening for a click. We're listening for a click here, anywhere on the body. Whenever a click happens, we are triggering this counter function. Counter function here has been assigned a value of whatever is going to be returned by another function. So if we're going to have a look at the counter, we can see f for a function, and we can see the body of the other function, of the inner function, because this is what is being returned. After the word return, this is the value of whatever comes out is going to be assigned to our counter. As you can see, outside in the add function body, we are placing let number, set it to 0, but this is in the add function, not after return. And in the return, this is another body of another function. This is what is the function add is returning. So the result of another function is returned by the add function. And in here, we can actually access the value of this variable from here, and we can also modify that value of that variable. If we wanted to make it a little bit more interesting, we could set number by default, or actually let's call it start. Let's set it by default to 0, and here instead of 0 we would give a value of start, which would do the same thing. But then if we wanted to do counter from 5, we could place here a different value, for instance 5. Counter is not defined because we are now using counter from 5. Cool. And the click should start from 6. If we wanted to change slightly, we could also do the pre-incrementation from here and instead of here. Right? But we can leave as it is for now. Let's go back to counter. Let's go back to 0. And let's leave it in this basic form. We're gonna do a few more examples, like a timer that is gonna be a task for you. We're gonna do one more example together, and then there will be a task for you so that you can be sure that you understand the concept and the construct, and you can handle anything that the future brings. Right, so we have one more to do together, and then after this one there will be one task for you, so you better focus now. I think this one is gonna be slightly more appealing because every time we work on people and users with names, I find that students find it easy to understand, easy to relate or associate. Well, much better, definitely much better than abstract X, Y, and Z, or counters and timers. Right, so I'm gonna create a const called user, assign it with an arrow function, and inside that arrow function, I'm gonna create a user name variable, give it a value of Joe, and another variable age. Let's say Joe is 20. inside that function user, we are going to create another function. This time, not an anonymous function, but a named function. So I'm gonna call it a beer permission. And regardless of whatever beer permission does, we are going to return beer permission. Cool. So about this. The only job of our beer permission function is to console log a message. We're gonna use template string, so I'm placing the backticks inside the parentheses, and we're gonna do hi, make an injection here of username, comma, and now we are going to create a condition using a ternary operator. To do a $sign and curly braces, we're gonna inject age variable here, and if it's higher or equal to 18 question mark, if this is true, then yes, you can buy beer, no problem. However, if this is not true, so this is a minor and this person is not legally entitled to get a beer at the pub, we're gonna display a message, nope, sorry, no beer for you, and a sad face. So this is it. This is our beer permission function. And underneath here, we are going to create a const Joe and call our user function on the Joe. So first of all, we're gonna see what is Joe. We can see f for a function, and we can see that Joe is gonna call a user function here, and this is whatever is being returned by the beer permission, because user function returns beer permission, so basically this console log. So now, instead of seeing what Joe is, let's see what Joe does. Let's call a function. Go, hi Joe, yes, you can buy beer, no problem. If we, however, adjust the age to 12 and save it, let's see if Joe can buy his beer now. Hi Joe, nope, sorry, no beer for you, because he's a minor. I hope you see what is happening here apart from the beer permission and whether Joe can or cannot get a beer. This is us making these references to username and age that are declared in the other function and us using them in the inner function here. So as soon as user is being called, this function stops existing, so it's no longer active, and its only job is to return beer permission function. So this beer permission function is being executed, but at this point, normally, since user function doesn't exist anymore, those variables shouldn't be alive, but because these references have been made, they are allowed to exist and we can modify them as well. Let's make it a little bit more complicated or a little bit more interesting. So let's introduce variables. Name. If no name is given, let's set it to an empty string, and age here. So username, instead of hard-coded Joe, is gonna receive name, and age is gonna receive age. If we don't want to have it all the same, I'm gonna change it to user age, and this leave age here, and update our code injection here. There you go. Just to make it slightly different so that it's not as confusing which age is what. Cool. So every time it's different. Save it. And we will have to now give the name. So Joe and 3. Save it. Again, let's call Joe. Still no beer for Joe because he's only 3. If we create another const Lucy and call user on her, give it name Lucy and the age of 19. Lucy is 19. It's called Lucy. Actually, let's call it inside here. I've got Joe and Lucy. We're calling one by one. And we can see, hi Joe, no, sorry, no beer for you. Hi Lucy, yes, you can buy beer, no problem. So these closures work. It's magic. We can have those references being made in 2 separate functions, and every single one has its separate kind of scope and separate closure. If, however, we create now const called no name, and we are not going to pass anything in here, and call it, save it, oh, I'm calling user. I don't want to call user, I want to call no name instead. So you can see that no name has been given no name and also no age. Since there is a default name in here as a parameter, it receives an empty string, so it just skips the name. But the age, since it's not given, here the reference is made to the user age that is being given the value of undefined. And undefined is it higher than 18? Evaluates to false. So in this case, it's going for no, sorry, no beer for you, because if no age has been given, it has been evaluated to undefined. So I hope this concept is now a little bit clearer, how those closures work, how we make references to something that is an outer scope in the function that now at this point no longer exists, but we can still have those variables stored in the other functions. Cool, and good luck with this new task, with this task for you. The time has come and it's a task for you. I think this is not exactly the easiest task. It's quite difficult. We've discussed in the past, in the previous classes, many things that you have to use for this one here. So it's not like there's something new or really surprising. It's more about putting those mini bits and pieces like mini pieces of puzzles together and making the bigger whole out of it. So basically, we are here to practice closure, and this is the project. The timer of how many seconds you've spent on the web page so far. You're gonna need a function returning another function. We're gonna have to close in the outer function a scope for those seconds, and then in the returning function, make the use out of the value provided by the outer function scope. And update it every second. The best way to update things every second, meaning at given intervals. This is my hint for you, and I hope you're going to do really well with this task. If you don't manage on your own, don't worry, we'll do it together in just the next video. Please have a try. So, good luck. If you managed on your own, this is absolutely excellent. This means that you're exactly where you should be with your knowledge and skills as far as closure is concerned. Or if you didn't, then let's do it together, and let's make sure that you go back to this task again in a couple of days and try again on your own without picking. Cool. So first thing, we need a function. I'm going to create const clock and a value of an arrow function. Inside that arrow function, we're going to create let second and give it a value of 0 for now. And another thing that we will do, even though it's not like it's absolutely necessary here, because this value is going to be like overwritten later on. Let's do a document body text content, and we will do 0 concatenation with seconds. Cool. And this is gonna return, this is gonna return another function called timer, and we need to declare our timer first as well. Const timer equals also an arrow function, and the job of our timer function is going to be to increment seconds. So we're going to do seconds plus plus as before, and also document body text content. But rather than set straight away 0 at the beginning, we need 0 at the beginning, but here we are going to need our actual seconds. So we've got seconds concatenated with the string seconds. Here we are returning the value of timer, and at the end we are going to create another function called start, which is going to be calling that clock function. So whatever is being returned by clock, which is timer, this whatever is here is going to be executed by our start. And to make that work, we're going to set an interval, and as the first parameter our start function that we want to release every second, so 1000 milliseconds. Cool. And now let's save it and let's see how the magic is working. Cool. So basically, not sure if I stressed it enough. I hope I did. That variable from here can be used here. It's not only accessed, but also it can be modified, meaning this is not a copy that whenever the timer has been called, it made its copy of seconds. This is an actual live connection. So it's accessed seconds and it created the reference. Reference is not a copy. So these seconds from here are actually updated. They are very much alive. The reference has been made, the link exists, and those same seconds are updated every second by this weird chain of reactions. Of course, set interval that as the first parameter receives a function, then we say how often or was the interval between calling that function. We are expecting 1 second every time. So every second we want the start function to be triggered. Here is our start function receiving the returned value from clock. Since clock is returning another function, this is what happens. Seconds starting from 0 are updated, incremented by 1 every second. The text content of the body is also updated every second. And this is no longer needed to be discussed because we know that this function from here returns this function. Hence, when we call start, then we call clock, and eventually the timer is being called. And this is exactly how closure works. We can access seconds. We do not make a copy, but we make reference and we work on those same seconds from here.